Hey guys, how's it going? It's Paul back again with a new video. Today I'm going to be going over some solids problems for General Chemistry 1. When I was taking it, these problems were pretty difficult for me, so I want to help you guys out and share two practice problems that I was able to do and that I went step by step through. So I hope you guys enjoy. Feel free to subscribe and leave any comments. And so let's jump right into it. So for our first problem here, it says crystalline aluminum has a cubic structure. The unit edge length is this number here, 4.440 times 10 to the negative 8. The density of solid aluminum is this number given here. So first off, let me write what I know already. So what I don't know here is the cubic structure of this solid. So again, it could be simple cubic structure which contains one atom. We have body centered, which is two atoms, and then we have face centered, which is I believe four atoms. So essentially, what we need to find is how many atoms are in one unit cell. So here's what I know. I know, and you should have learned this. If not, it's pretty simple. But essentially the volume of a cube is side times side times side. For these cubes, since all of the sides are equal, it's going to be side times side times side. So a cube is equal to the volume of the cube, or volume of the unit cell. And what we also know is the density, 4.096 grams. So what I'd like to think of is this unit here is essentially, this is the volume of the unit cell. And so also, if we're going to convert to atoms, we know that we need to go through the molar mass here. So immediately I'm thinking, okay, my answer is going to end up with atoms per unit cell. So how can I get this? Well, let me first solve for the volume of the unit cell, which is going to be this number cubed. Let me type this into my calculator. I'm going to get 8.75 times 10 to the negative 23 centimeters cubed. Again, this is the same thing as, this is the same unit here. So again, to get atoms, we're going to have to go through the molar mass, and we're going to want the volume of the unit cell on the bottom, atoms on the top. So the way we're going to do this is we're going to start off with the volume of the unit cell, which we just found right now. Centimeters cubed. We'll just go ahead and put 4.096 grams. Sorry for my dogs barking in the background. So we have grams of aluminum. Again, we're going to have to go to moles, so let's use the molar mass. Grams of aluminum is 1 mole of aluminum. 26.982. So moles of aluminum, 1 mole aluminum has 6.022. Again, using Avogadro's number to get to atoms. And so let's see how this stuff cancels out. So this is going to cancel out with this. Grams with grams. Moles with moles, and so we're left with atoms. However, our last unit is going to be atoms, obviously, per unit cell. So if you type this into your calculator, did a small error here. This should be this is a negative. So when I type this in, I get 8 atoms, rounded off, 8.00. So I round it off and I get 8 atoms per unit cell, which is the answer. So one thing that you can check to see if you did it right, you're going to see that this cancels out with this, and that's what we want. Again, another thing is that you have unit cell on the bottom, everything cancels out nicely, and so we know that we did this problem correctly. Let's do one more problem. This one is a bit harder, but we're going to approach it the same exact way. The volume of a manganese atom is 9.21 times 10 to the negative 4. So we're giving, manganese crystalline is a face-centered cubic system. What is the density? Again, density is grams in this case. This is the same as volume of the unit cell. Now, I'm thinking to myself, are we given the volume of the unit cell? We're giving the volume of the atom. And we know that the equation for volume of the atom is volume of a sphere is equal to 4/3 pi r cubed. What else do we know? We know here we're giving the cubic structure. So I'm just gonna write down this volume of the unit cell, which again is the same as this. These two are exactly the same, and are used to convert from one thing to another. And the last one that we need is A, which is side length of this cube. Again, we're not giving the side length, we're giving the volume of the atom, is equal to 4r. And what I did when I was taking General Chemistry 1 was I just memorized, I literally just memorized this. This is for the face-centered, and for body-centered, it's 4r divided by square root of 3. So literally what I did was I just remembered that. That was helpful to me, so I could do these problems. And so what we're going to have to do here is we're going to have to start off with 9.21. Excuse my writing. 9.21 times 10 to the negative 24 centimeters cubed. And we're going to equal this to the volume of the sphere. Here it's literally just algebra. Multiply this side by 3. We're going to be solving for r, because once we have r, we could plug it into this equation, and then we can get the side length, which is what we want. Because ultimately, to get this part, we're going to need the volume of the unit cell. And the grams, we'll do that after, but for now, we're solving for r. So 4 pi, I'm going to divide both sides by 4 pi. 4.1 and 8 times 10 to negative 24 equals r cubed, cube root both sides, and cube root for both sides, and r is equal to 1.3 times 10 to the negative 8. Okay, so now we have r. Now let's just plug it into our equation here, which is again based on the cubic structure. We either use this one or this one, or simple cubic would be 2 r's equal to a. So just plug this in. 4 times 1.3 times 10 to the negative 8 divided by the square root of 2. Then we're going to get a from this. So and we get a is equal to 3.68 times 10 to the negative 8. Again, what we want is the volume of the unit cell. And so we're going to cube this number. 4.97 times 10 to the negative 3. I like to do it before I plug it into the equation. Actually, this is the only way to do it. So once we have this, so we know that the volume of the unit cell is equal to 4.97 times 10 to the negative 23. So how do we get grams? To get grams, we're gonna have to go through the molar mass, but they don't give us grams. But however, since it's face center cubic, we know that 4 atoms are present in this cubic structure. So I'm going to start off with 4 atoms of non-aluminum, manganese, 6.022 times 10 to the negative, to the 23rd power, 1 mole of manganese, 1 mole. Manganese has how many grams? We go to the molar mass, 54.938. Plug this into our calculator. And we're going to get 3.65 times 10 to the negative 22 grams of manganese over 4.97 times 10 to the negative 23 volume unit cell, or it's the same thing as centimeters cubed in this, which we're given here. So I'm simply going to plug this into my calculator. And I'm going to get 7.34 grams per centimeters cubed, which is the answer that we're given here. So we did it correctly. Again, these problems, practice will help you get better at them. What helped me was remembering these equations that I gave you guys here, as well as understanding that once I find the edge length, I can then find the volume of the unit cell. Also knowing how many atoms are in each cubic structure, and just basic stoichiometry from that point. So I hope you guys learned something, and I'll see you guys on the next